Miss Amy's Math.
In today's lesson, we'll be evaluating logarithmic expressions. But first we need to discuss what is a logarithm and what is a logarithmic expression. Here we have an example of one. It can be read the logarithm of 8 to the base 2, or more simply, log base 2 of 8. Just like the expression 3 plus 4 is equal to some number, the expression log base 2 of 8 is also equal to some number. That number is the exponent that our base 2 is raised to get 8. Since 2 cubed is equal to 8, our logarithmic expression is equal to 3. So a logarithm is basically just an exponent that the base b is raised to get the number n. Now let's work some examples. For example 1, we want to evaluate the expression log base 5 of 25. And since it's just equal to some number, I'm going to go ahead and write equals x. And remember, x is basically just an exponent. It's the power that 5 is raised to get 25. Since 5 times 5 equals 25, the value of our logarithmic expression is equal to 2. Our next example is very similar to the first. We want to evaluate the expression log base 3 of 81. I'm going to go ahead and write equals x. And we know that x is just the power that 3 is raised to get 81. We have 3 times 3 is 9, times 3 is 27, times another 3 is 81. So 3 to the 4th power equals 81. And our logarithmic expression equals 4. For example 3, we want to evaluate the expression log base 8 of 1. I'll go ahead and write equals x. So our expression equals the power that 8 is raised to get 1. For this example, we have to recall our exponent rule that says any base raised to the 0th power is equal to 1. Applying this rule, 8 raised to the 0th power equals 1. So our logarithmic expression is equal to 0. For example 4, we want to evaluate log of 100. This is an example of the common logarithm, which has a base of 10 and is usually seen written without its base. So I'll go ahead and write equals x, and we know that the expression equals the power that 10 is raised to get 100. Since 10 squared equals 100, the value of our logarithmic expression equals 2. For example 5, we want to evaluate the expression log base 49 of 7. But first, we need to recall that radical expressions can be rewritten with fractional exponents. Now let's evaluate. I'll go ahead and write equals x, and I know that my expression is equal to the power that 49 is raised to get 7. Since 7 is less than 49, I know that my exponent has to be less than 1. We know that the square root of 49 is equal to 7. So we can rewrite it as 49 to the 1/2. And our logarithmic expression equals 1/2. There's one more thing we need to discuss. When evaluating the log with any base b of 0 or of a negative number, the value is actually undefined. Since the log function is only defined for bases greater than 0, there's no power that we can raise b to that will equal 0 or a negative number. And that's why these values are undefined. And that's it for this lesson. If it helps you in any way, please give it a like or let me know in the comments.